Your objective for lesson 9 is I will analyze different rectangles and reason about their area. Okay, you're going to need the piece of paper in your binder that has the area template that looks like this, and you will need to take it out of your binder because we will be using our scissors today to cut it. So if you want to go ahead and have your scissors and that piece of paper ready, you can do that. Okay, so how can we cut this grid to get two equal rectangles? So I want you to look at the how many rows we have, and when we're counting up and down, and I want you to do this with me. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could make this even and make it equal because 10 is an even number. So all we really have to do is break 10 in half and make that two fives. And you are going to cut apart this large rectangle into two small rectangles that look like this, where you've got 5 rows and 5 rows. So I want you to go ahead and cut out the rectangle to where you have two pieces that look just like this. Whenever you have that ready, I want you to push play. Okay, so you're also going to need your problem set, and we're going to work on some of the problem set during our concept development. So for number 1 on your problem set, part A, it says draw and label the side lengths of the two rectangles that we just made. So you're going to draw two rectangles on your paper, and then we're going to label the side lengths. Okay, so this paper that we're working with, these squares are square centimeters. So whenever we are labeling the side lengths of these rectangles for problem 1A on your problem set, we're going to use numbers like we normally do, but we're also going to use centimeters. So on this rectangle, we see that there are 5 rows. So on one of your rectangles, you're going to put 5 centimeters. And you're also going to do that on your other rectangle since these are two equal rectangles. So make sure you are putting this on your paper just like I have it on the screen. And then I'm going to go and I'm going to count across the top and see how many square centimeters are in each row. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of these is going to have another side length of 10 centimeters. So make sure you are labeling this on your problem set just like I have right here on the screen. If you need to push pause, you can do that. Okay, so now we're going to move on to part B and C of the problem set. We're still working with the same rectangles. So how can we find the area of one of the rectangles? That's what we're going to try to figure out. We know that all we have to do is label the side lengths to help us find the area. So we know that this side length is 5 and we know that this side length is 10. So on your board, I want you to write down what is the area of one of these rectangles. And remember, we're using centimeters, so you're not just putting down the number, you also have to put down the words that go with the area. Whenever you're ready to check your answer, you can push play. So the area of one of the rectangles is 50 square centimeters, and we know that because all we had to do was find 5 times 10, and we know that 5 times 10 is 50. So what is the area of the other rectangle, and how do you know that? Well, since we have two rectangles and they're equal, meaning they're the same exact rectangle, then we know that the other area of the other rectangle is also going to be 50 square centimeters. So we're also going to be working on the problem set of how can we find the total area of both of the rectangles, meaning what equation can we use to find the area of both of these rectangles together. So let's look at part B and C of the problem set. And part B says write an equation to find the area of one of the rectangles. So you're going to do that. And then I also want you to write a sentence telling me what is the area of one of the rectangles. Whenever you have that done, I want you to push play to check your answer just for part B. Okay, so the equation that you would have used is 5 times 10 is 50, just like we had discussed. And then the sentence I was looking for is the area of one of the rectangles is 50 It should say square centimeters. Okay, so if you need to correct anything right there, please do that before you move on to part C. Write an equation to show the total area of the two rectangles. So if we know that both of these rectangles have the same area, then what equation can we use to find the area of both of these rectangles together? And then I want you to write a sentence that tells me what is the total area of both rectangles. Whenever you're ready to check your answer, you can push play. Okay, so the equation would have been 50 plus 50 because we've got an area of 50 and another area of 50, and when we add those together, that gives us 100. So the sentence I was looking for is the area of the two rectangles is 100 square centimeters. So make sure you have this done before we're moving on any further in the problem set. Okay, so now you're going to take those rectangles and you're going to place them next to each other to make one long rectangle just like you see right here. Okay, so what do you think the area of this long rectangle is, and why do you think that? Okay, well, we just figured out the area of both of the rectangles, so just because we moved them together doesn't change that. So we're going to say that the area of this whole rectangle now is going to be 100 square centimeters, just like it was when we added both of them together. So for number 2 on your problem set, it said place your two equal rectangles side by side to create a new longer rectangle, which is what we just did. And it says draw an area model to show the new rectangle and label the side lengths. So remember, an area model is just a rectangle, it doesn't have any of the squares inside of it. So you'll need to draw a rectangle, and you're going to need to label the side lengths of that rectangle. Whenever you're ready to check your answer for number 2 on your problem set, you can push play. So your area model should look like this, and if you notice, this side length of the rectangle is pretty long, so you should have a longer side on this side of your rectangle since this is 20 centimeters and this is only 5 centimeters, and it matches what your rectangles look like on your desk. Make sure that you have it labeled correctly for number 2. So what multiplication fact could we have used to help us find the area of this longer rectangle? I want you to write that multiplication fact on your board and push play when you're ready to check it. Okay, the multiplication fact that you would have used is 5 times 20. Okay, now we're going to move on to part B. How can you solve this multiplication fact? So we have learned how to solve multiplication facts with using multiples of 10 before, and a 20 is a multiple of 10, so you're just going to choose whatever strategy is best for you, and you're going to use that strategy to help you answer part B of problem 2 and finding the area of the longer rectangle. So make sure that you're not just writing down what is the area of the longer rectangle, but actually write down the equation or the equations that you use to help you find the area of this longer rectangle. And make sure you're writing in the sentence what the longer rectangle is. Whenever you're ready to check your answer, you can push play. So you could have just done 5 times 20 equals 100. Or I wrote this down wrong. You could have done 50 plus 50 equals 100, since we knew that with our two different rectangles it was 50 and 50, and that gave us 100. So the sentence I was looking for is the total area of the longer rectangle is 100 square centimeters. So make sure you have your equations that you used and the sentence telling me what the total area of this longer rectangle is before you move on. Okay, we're going to finish the rest of the problem set now. Okay, number 3 on your problem sets. Yuhara and Rahima used square tiles to make the rectangles shown below. Part A says label the side lengths on the rectangles above and find the area of each rectangle. So for Fuhara's rectangle and Rahima's rectangle, I want you to go ahead and label the side lengths. It doesn't tell us that we're working with inches or centimeters, so we're probably just working with square units. So all you have to do is use numbers to label the side lengths on each rectangle. So I want you to go ahead and do that for both rectangles. You're only labeling the side length, and then we'll move on to the rest of part A. When you're ready to check your answer, you can push play. So for Furara's rectangle, one side length was 4 and this side length was 6. And for Rahima's rectangle, one side length was 4 and the other side length was 7. So now we have to find the area of each rectangle, and I went ahead and put down the way I would like for you to write it on your problem set so I know which rectangle we're talking about. So make sure you put Furara's rectangle equals and Rahima's rectangle equals. And we're going to write down what is the area of both of these rectangles. And since we're working with square units, make sure you're writing that whenever you write the area. So I want you to go ahead and complete part A of the problem set, and whenever you're ready to check your answer, you can push play. So Fuhara's rectangle is 24 square units, and Rahima's rectangle is 28 square units. Okay, so for part B, it says Furara pushes his rectangle next to Rahima's rectangle to form a new longer rectangle. Draw an area model to show the new rectangle and label the side lengths. So this is just what we did in the concept development and on the front page of this problem set, where we had two rectangles and then we pushed them together to make a longer rectangle. Because if you notice up here at the top, whenever we're looking at their rectangles, both of these side lengths are 4. So whenever I push them side by side, it's the same exact thing. The only thing that's going to change is the total length of this side length, because now that we're pushing them together, it's going to be a little bit longer. So on part B, you're going to have to label the area model with the new side lengths of the new longer rectangle. Make sure you're just putting the numbers, since we don't know if it's centimeters or inches that we're working with. So whenever you're ready to check your answer for part B, you can push play. Okay, so the new longer rectangle would have looked like this. I know that this side length is going to stay 4, but this new side length is 13, because for Fuara's rectangle, the side length was 6, and for Rahima's rectangle, the side length was 7. So whenever I add 6 and 7 together, I get 13. Part C says, Rahima says the area of the new longer rectangle is 52 square units. Is she right? And explain your answer. So now you're going to have to do what we normally do whenever we find the area of a rectangle. You could do 4 times 13 and try to figure that out, or you could go back up here to the top, and you know that Fuhara's rectangle was 24 square units, and you know that Rahima's rectangle was 28 square units, and you could just add those together to see what the total area is. So I want you to go ahead and work on part C. Make sure you're answering in a complete sentence, and make sure you're explaining how you got your answer. Whenever you're ready to check your answer, you can push play. So is she right? Yes, she's right, because the area of the longer rectangle is 52 square units, and I know this because the sum of 24 and 28 is 52, because all I did was take both areas and add them together, and that gave me 52. So as long as your answer is similar to what I have, then you are correct. Number 4 says, Kira says she can find the area of the long rectangle below by adding the areas of rectangle A and B. Is she right? Why or why not? So notice in this picture that here's rectangle A, but here's rectangle B, and rectangle B is in part of rectangle A. So think about towards the beginning of the module when we talked about leaving no gaps and not having anything overlapping, and how that helps us find the area. Make sure you're thinking of that whenever you're explaining why she's right or why she's not right. Whenever you're ready to check your answer, you can push play. Okay, so the answer is no, because they are overlapping, and that's really all you needed to say, because we talked about before, in order to find the area and for the area to be correct, there correct, there cannot be any overlapping. And so since part of rectangle A is on part of rectangle B and they're overlapping, that's not really going to give us what the true area of these two rectangles are. Okay, so now we're going to move on and work on the exit slip. Make sure you're answering all parts of this before you bring it to me, and whenever you're done, make sure you bring that to me so we can check it. What?